Yeah, hello guys. In this tutorial, I'm going to explain the same question that we have previously done, and the question that we are currently discussing is 117 on leetcode platform, and the title of the question is populating next strike pointers in each node, second variation. Previously, question number 116, I guess, that is actually the variation one, which doesn't have specified as one like that, but it's a standard and the first version of the question, and this is the second version. That's the reason to make difference between them. They have mentioned the two Roman number on the title of the question. So you can search the question on the platform lead code and the same question. There is nothing, absolutely nothing difference, but just it's a small thing is there. That's where the whole question is actually being differed from 116 to 117. That is nothing but in the question 116, they'll actually give a complete perfect binary tree where every leaf node completes at the same level. But in question number 117, we don't expect that the given tree is actually a perfect binary tree, because that's what they meant us to do. That's what we need to actually point our left pointer to the right, and we need to be aware of that. We should actually connect when that pointer is not null. We shouldn't do anything. So the main agenda of this question is we need to traverse the pointers carefully and connect the right pointers, and the remaining part is same as the question. And so the only difference is they're not giving the perfect binary. They'll just randomly throw you a fucking binary. They'll say you to connect the pointers towards. So I brought a brilliant approach for you guys to understand in a great way for this portion of version 2. And if you see, everything is same. The image that they gave in 116 was also being at here also. So let's dive directly into the code. What we're gonna do with an image. Yeah, this is the tree, right? So we don't expect where is our leaf node. Let me take my red pin, and the 7 else, yeah. So what we'll do is, if we for every level we'll just have a new dummy linked list, and that should actually start pointing from here, the node, the leftmost node. Means let's dry run actually, and we'll done with this approach. Node equals to current, node current equals to root. So current is a pointer that is pointing towards root, which is in this case 1, while current value is not equals to null. Yes, that's true, because 1 is not equals to null. And then create a dummy node 18. Let's create a dummy node, and then it has a tail pointer. I'm representing with t. And then we do actually have another condition that while current value is not equals to null. Yeah, that's true. Current value is not equals to null. Then current dot left value is not equals to null. Is that true? Current dot left value, yes, that is not equals to null, because current dot next value, sorry, current dot left value is actually 2. So what we'll do is tail dot next equals to current dot left. It means tail dot next should point to, sorry, I shouldn't have been drawn that long. What we need to point, current dot left. Current dot left is actually 12, and this is the dummy node, remember that. And then we move our tail pointer to here, and our tail pointer is pointing to here now. Then this is done, this condition is done, and then we are at here. Current dot right value is not equal to null. Yes, current is actually 1 and current dot right value is not equal to null. That's true. Then we need to connect that temp, not temp, tail dot next equals to current dot right, and then we need to move tail dot tail equals to tail dot next. But first we need to create the node with 3 and move our temp pointer, and then we need to then we need to, what we need to do, and then tail is actually being moved, and then finally current equals to current dot next. What is the current? Current is actually 1. Current equals to current dot next means we are actually pointing towards something, nothing, which is null. So currently our current pointer is actually null. So we'll go from here to we are ending here, and this is the ending of this while loop. So we'll check here condition null value is not equal to null. Is that true? No, because null is actually equal to null. So we don't execute this condition. So we'll come out of here, and what is there? Current equals to dummy dot next. So current is actually now pointing to dummy dot next, which is actually 12. So current is pointing towards 12. Why the fuck 12 came? It's actually 2, right? I need to make it 2. This is in 12. Sorry, my bad. Just remove there isn't much thing because that's just a value, but the logic remains same. So 2, and we don't actually have this one now. Remember, if you see here, you are actually pointing your child nodes at every level. You are currently at this level. In this level, you are actually pointing. You are creating a dummy linked list and point your nodes to the child. You're creating a new linked list and point your nodes to the child ones. That's what you are doing in this iteration also. If you observe that we are actually remove this one, and our current is pointing towards 12, and that's the end of here, and it's the end is nothing but it's actually a while loop will come from here to here. And while current value is not equal to null, is that true? Yes, current value is actually 2. So you will actually create a dummy linked list, and again, what is the dummy linked list? Again, it's 18. You will repeat this up to h levels. How many number of levels? Height of levels. And we created it, and it also has a tail pointer. You're just repeating the same thing, nothing much. Then you are checking the condition here. While current value is not equal to null, yes, that's true. Then current dot left equal, while current dot left, if current dot left value is not equal to null, is that true? Yes. 2 dot next value, 2 dot left value is not equal to null. Yeah. Yes. 4 is not equal to null. Then tail dot next equal to current dot left, which is actually 4. You're pointing pointer to the 4, and then tail is moved by 1, and then you're checking this case current dot right is 5 actually null? No. Then tail dot next equals to current dot right. So you're pointing towards 5 and move your tail pointer by 1, and your tail pointer is at here. If you see here, we are actually moving level by level. Previously we done this level, and we will complete this level now. You can see clearly how I'm gonna do that. And we have done this one also, and we are at here. Current equals to current dot next. Current equals to current dot next means current is actually 2. Then we are actually connecting it to here. We are moving here, and what we'll do, we'll go here again top, and we'll check these three values not equal to null. Yeah, that's true. So we will do the execution of this loop for this time, and current dot left value, which is actually null. Is that true? Yes. So we won't execute the if condition, and we will stop executing because current dot left value is actually null. So we won't do this one, and we'll go for here. Current dot right value is equals to null. Is that true? This actually satisfies because current dot right value is not equals to null. 7 is not equals to null. So what we'll do is just we connect the pointers towards them. Did I actually done the connection? No. Yeah, I haven't connected this one. This is being connected because if you see here, you are actually connecting that. The same thing is here also. We are connected this one, and then what we are actually doing here, we are being executed this one, right? I stopped and connected this one, and now we need to do this one. Current dot right value is not equal to null. Yes, 3 dot right value is not equal to null. Okay, tail dot next equals to current dot right. Tail dot next. What is tail dot next? Tail dot next equals to current dot right. Tail dot next is nothing but 5 dot next equals to 7, means we are connecting this one. So we have been done, we are doing the same thing, brother, nothing difference. Even that is not a perfect binary also, it doesn't matter at all because we are actually moving our pointers carefully. That's what they want, and that's what we are doing. But I can't show you in this example because it's a perfect binary. We can actually do that. And even though it doesn't matter if you gave me any tree, I'm gonna do that. I'm gonna conquer that. So now I need to move my tail pointer to here, and then current equals to current dot next. Current is actually 3, and we'll move here, which is going to be null, and we are pointing towards null. and we'll come here and current value is not equals to null. No, so because we don't enter here and we'll go here current equals to dummy dot next. Current equals to dummy dot next. Dummy dot next is actually 4 and we'll remove this part, and current pointer is actually pointing towards 4 here, and then the end here, and we'll go from top, and current pointer is not equal to null. Yeah, yes, that's true. 4 is not equal to null. Then we'll create a new dummy linked list node, which is again 18. We're actually repeating for every level. You're calling its child level nodes. If you see here, when we are at 1, you created a linked list for 2, 3. When you are at 2, you created linked list dummy for 4, 5, 7. 4, 5, 7. And here 2, 3 for when you are at root is 1. So that's what you are doing. Until you reaches this next is null, you will do the same thing for this third one also. And we created a dummy node with tail pointer towards pointing to it. And then while current value is not equal to null, sorry, here or what? Here, yes. Yes, 4 is not equal to null, then current dot left value is not equal to, sorry, that's not true, because current dot left value is actually null and current dot right value is actually null. Then move your current equals to current dot next. So current is actually pointing towards 5 and you're coming from top, current value is not equal to null. Yes, that's true, but current dot left value is null and current dot right value is equals to null. So you don't execute both them, and you will come here and you will do current equals to current dot next, and current value is actually pointing to 7, and you will satisfy this one, but current dot left value is not equal to null. That doesn't satisfy, so you don't enter the if condition, and current dot right value is also not satisfied for this node 7, and you don't enter there, and current equals to current dot next, and you are pointing towards null. And then the end of the while loop, and you are actually pointing towards null. Current equals to current, null is not equals to null. Is that true? No, null is actually equals to null, so you don't enter the while condition again, and that's the end of while loop, and current equals to dummy dot next. You haven't done anything for this stage of linked list, because that's the end. You don't actually have a chance to do anything. So current equals to dummy dot next, so you're actually pointing your current as null, and then because dummy dot next is nothing but null, right? And at the end you are coming here, null is not equals to null, so that's not true. That's the end, and then return root. What is the fucking root? uh, Root is nothing but we haven't changed the root. Root is remains the root, so we'll return this value. It means the every single fucking pointer of right is being connected as we expected to do. We done that, we nailed that. Fucking go. Fucking go. Yeah, thank you.